This results in only a slight darkening of the moon. As the moon continues along its path, however,
Good evening and welcome to the Ford Amateur Astronomy Club live stream of the lunar eclipse tonight. As you see, we are well into the eclipse and we're sorry we got on late. We did have some technical issues to overcome due to the cold weather, and I'd like to put out a special thank to Doug Bach, who is a member of our club but has allowed us to piggyback on his feed of the lunar eclipse of January 2019. So as you see here already, we already have some areas of the moon that are being cut off by the Earth shadow. So we are about 1/3 of the way through the umbral eclipse. So let me show you a quick presentation to explain. Well, first of all let's talk about why we do not have a lunar eclipse every month. So first of all, it starts off with obviously there is a tilt in the moon. So as the moon orbits around the Earth, you see the Earth shadow streaming off into space, and you see the moon shadow. Now, as the moon passes
of the moon, and it occurs roughly once a month. At least twice a year, however, something quite different happens. The moon passes through the shadow cast by the Earth, causing it to look extremely unusual for a short period of time. From the Earth, the moon will appear to darken and turn a deep red.
Okay, so you see we're about 1/3 of the way into the eclipse, and what we're going to do is I'm going to show you a quick demonstration to explain why we don't see lunar eclipses every month. So let me just switch over to that presentation. And as you see, as the moon goes around, it passes through Earth's shadow, but the moon is at an 11-degree tilt, so it doesn't always pass through the shadow. It's either above or below the Earth shadow. And eventually, after so many iterations, it will eventually pass through Earth's shadow. And as it does this, this is when we see a lunar eclipse. So the reason why we don't see a lunar eclipse every month is because of the tilt of Earth, or of the moon's orbit around Earth. So let's quickly flick back to the live view about what's going on. And as you see here, we are making our way through the eclipse. We have two different views. One is through a large scope, and one is through a camera. The one on the right is through a camera that's 300mm. The one on the left is through a very large telescope, a 10-inch telescope. And so the view is not as good through the 10-inch telescope because it gives us a more magnified view than the camera will. So the camera kind of gives us a nice view from a distance, and the telescope view, which is on the left hand side, gives a more up-close view of
The change in its shadow is based on where the moon is in its orbit. We call this cycle the phases of the moon, and it occurs roughly once a month. At least twice a year, however, something quite different happens. The moon passes through the shadow cast by the Earth, causing it to look extremely unusual for a short period of time. From the Earth, the moon will appear to darken and turn a deep red before eventually returning to normal. This is called a lunar eclipse. If we were to look at what happens from space during an eclipse, it would go something like this. First, the moon passes through what's called the penumbra, where the sun's light is only partially obscured. This results in only a slight darkening of the moon. As the moon continues along its path, however, it enters what's called the umbra, where all direct light from the sun is blocked. But if the sun is blocked, why does the moon turn red? When light from the sun goes by the side of the Earth, it passes through a long and thick layer of Earth's atmosphere. Shorter wavelengths of sunlight, like blue, are scattered by the atmosphere, so by the time the light has finished its trip to the moon, more of the longer wavelengths, like red, are left over. On the Earth, the same thing happens at sunset as the ground you stand on gradually passes into night. As the eclipse ends, the moon leaves the umbra, returns to its normal color, and then leaves the penumbra, brightening and resuming its original cycle.
So as you see on the right hand side, which is the image taken by the camera, what's actually happening is you see some countdowns happening there on the right hand side. We're actually taking still images using the camera. So that countdown you're seeing is actually a pause between each individual shot, and then it runs through. It takes a photograph. It says busy, and then it does a download, and then pauses again, and then repeats the process. And it's taking 100. It's at image 128 out of 700, which is planned for this imaging run for tonight. So let's explain a small bit what's going to happen as we approach the